My name is Brant Cobb, and I'm coming to you today from a construction site where a shop is being built using cross-laminated timber panels, or CLTs for short. The foundation is treated CLT panels, and all the walls are untreated, but they will be painted and sealed to ensure a long life. This project, when complete, will actually have a negative carbon footprint. What does that mean? That means if you add up all the carbon releases from the harvest of the trees, to the manufacturing of the CLT panels, to the delivery here to the job site, to the assembly, that after you add up all those carbon releases, there'll still be more carbon sequestered in this building than was released during its construction. Actually, more than 17 pounds of CO2 per cubic foot of wood used in this structure will be sequestered. Now, when you compare that to concrete that releases over 20 pounds of CO2 per cubic foot used, or even steel that releases over 30 pounds of CO2 for each cubic foot used, it is a significant difference. Now, this is a block, a CLT panel, if you will, and judging by the rings, the aging rings, growth rings in the panel, in the block, these carbons were sequestered roughly 35 years ago, or about 1986. It was harvested in 2020. This picture is of a job of wooden piling being driven to a 45-ton load rating for the construction of a CVC pharmacy in Leesville, Louisiana. This is a picture of a bridge that was built just in 16 days in Independence, Kansas. Both of these projects are good examples of CO2 that is sequestered by utilizing wood instead of concrete or steel. I like to think of CLT panels as a canvas for engineers and architects to design our future with. A future where our structures actually remove and store our CO2 footprint. Sound barrier walls, structural girders, traffic barriers, whatever we need to build. Building for the future, where our carbon footprint of today is sequestered, is the best way to ensure that future generations will have the same opportunities.